You have the underlying philosophy, the definitions of what is value. What are the challenges to doing this empirically? And to understand that, and particularly when we get into things that are more difficult to value, as we were talking about, as we go across the spectrum, from things like recreation to aesthetics to existence of ecosystems, these same principles are going to hold. So let's understand the basics. Using Chesapeake Bay, Lisa and I work a lot on oysters in the Chesapeake. We have a large growing oyster aquaculture industry. At least it was growing before COVID. If we go out and, you're all scientists, you deal with data, we go out and collect data, and we get this upward sloping demand curve. And what does it tell us? So these are oyster farmers, and we're saying that the reason that curve slopes upwards is that if I'm a farmer, I'm going to produce as efficiently as possible on my my oyster grounds that I'm leasing. But eventually I'm going to have to, move into less productive grounds, either on my own lease, or that's true for the industry as a whole, that, the most efficient growers come in first, they get the best growing bottom, and then they move at folks who want to get into the business, move on to less productive areas. So the more you end up producing, the higher the cost of the production is going to be. Why is this important? So you all know basic, supply and demand. There's a market equilibrium. So there's a price that's set for these oysters based on the demand and the supply. So let's look at, you've got that market price, but let's look interior within that farm, that this amount of production for that farmer only cost this amount on the graph to produce. At the market price, it costs exactly the amount that, if it's 50 cents an oyster or whatever you're measuring it, if it costs 50 cents and you get 50 cents, that's where the market equilibrium is. But because of that upward sloping supply curve, the cost of producing a smaller amount is less. And you don't get less, for that oyster that you produced at a lower volume, you get the same price. So for that amount of production, you're getting a surplus in terms of your payment, the difference between the market price and the cost. This is the revenues that you get. You get the market price times the amount you produce. This is the cost. This is what we call the producer surplus. Basically, you've added up for all the production below the market price, you're getting a surplus. It's most at the smaller quantities. And as you move across that demand curve, it gets less and less until it disappears. And it gives you that triangle, that producer surplus. This is, from a production point of view, the equivalent of the difference between, of that net benefit of that production, between the maximum willingness to pay and what you're willing to pay. It's the producer equivalent. We call that producer surplus. Let's look at the other side of the equation, the demand curve. You might ask, like, if you went out and got the same data on prices and quantities, how do you get two curves, one sloping up and one sloping down? The answer is that there's a lot of things we haven't accounted for here on the graph in terms of substitute products, income, affect demand differently than they affect supply. But if you go out and collect the price and quantity data and you estimate a demand curve, you'll get something like this downward sloping demand curve, which is basically saying the more available a product is to you as an individual or to the population, the less you're willing to pay for the next unit. We have a similar surplus concept on the consumer side. So again, we have the market price, and now we look in the interior at a lower amount. As I said, the more of the item that is being purchased, the lower the price because of the lower the demand. So at the lower amount of production, the price that you're willing to pay, your total willingness to pay, or your maximum willingness to pay, that's what the demand curve is measuring, and the market is higher than the the price that you actually have to pay for that product. Again, you don't get priced differently for each quantity of oysters that you buy. You pay the same price for all. So again, there's a surplus that's created in this difference between the maximum willingness to pay and what you actually pay for the unit, for that individual unit. And then we do the same thing. We do it across all of the units that are on the market. So this is the total willingness to pay added up across all the production. Here's what you actually have to pay. And then the net benefit is the consumer surplus. So it's those producers and consumer surplus. Those are the net benefits about what we're trying to measure in terms of value. And I'm using this example of, an oyster farm that it's, doesn't have all the qualities of other sort of environmental issues that we have to deal with. These lines aren't necessarily straight lines, maybe more calculus than geometry in reality, but it's just, this type of calculation, the area of a triangle, to calculate what that producer surplus is. So it's really not, that difficult of a calculation when you have a well-formed market where you can observe prices and quantities and estimate what the demand and supply curve looks like. Here's an example where you might have water pollution that makes it more costly to produce oysters. So for any given quantities of oysters, the supply curve shifts up because it's more expensive to produce because of pollution impacting negatively the oyster production. And so all you're doing, what you're interested in, is what's the impact of that on the producer and consumer surplus. So here you get a different calculation for the producer surplus with the pollution than without, and you're just comparing the differences between those two. And then the same thing would happen. The consumer surplus would also be different under the two circumstances. It'll be lower, so there's a negative impact. So the total societal impact from some pollution impacting oyster production is the loss in consumer surplus and the loss in producer surplus added together. It's as basic as that. So that, as I said, is how we would go about doing these calculations if we weren't dealing with difficult to measure environmental and resource calculations.